In this lab, you will use Scapy, a powerful and flexible Python-based packet crafting and network scanning tool. With Scapy, you can construct custom packets with specific protocols and fields. This makes it an ideal tool for testing and analyzing network communications. In Part 1, you will investigate some of Scapy's capabilities and review the contents of the IPv4 packet header. In Part 2, you will use Scapy to sniff network traffic. In Parts 3 and 4, you will create, send, and capture custom ICMP and TCP send packets. Part 1 is investigating the Scapy tool. As with most tools you use in this course, Scapy should only be used on networks you own or have written permission to access. Completing this lab in your Kali VM is safe. Step 1 is to review the Scapy documentation. Follow the link in the lab and read the introduction by Scapy's creator, Philip Biondi. Step 2 is to launch Scapy and use the interactive command mode. I already have my Kali VM open. Let's open a terminal. Scapy requires root privileges. Let's enter sudo su so we have persistent root access. Next, enter the Scapy command to launch the Python interpreter and load Scapy. Enter the ls function to show a list of all the available default formats and protocols provided by Scapy. Here are the default formats for TFTP. Step 3 is to review the IPv4 packet header. This should be mostly reviewed from your previous courses. You can review this on your own time. We won't review it here except to see that you can have Scapy list the fields of the IP header by entering the function ls and providing IP as the argument. Part 2 is to use Scapy to sniff network traffic. Step 1 is to use the sniff function to start the capture of the default Ethernet 0 interface. Open a second terminal and send 5 ping packets to cisco.com. Return to the window where Scapy is running and stop the capture with Ctrl-C. You get a summary of the packet types that were captured. Assign the output of the sniff function to a variable. We're using the letter A here. Note that the underscore is used to temporarily hold the output of the last function executed, which was the sniff function. Now use the summary function to view the captured output. Step 2 is to capture and save traffic from a specific interface. Take a look at this topology, which represents all the devices inside your Kali VM. You will now capture traffic between the 10.6.6.1 interface and the Gravemind server at 10.6.6.23. Open a new terminal and enter the command ifconfig to list all the interfaces available on the virtual switch router. Locate the name of the interface connected to 10.6.6.1, which is BR internal. This time, when you use the sniff function, specify BR internal as the interface you want Scapy to monitor. The Gravemind server is currently running on your Kali VM. Open Firefox and enter Gravemind's IP address, 10.6.6.23. Minimize Firefox and return to the Scapy instance. Use Ctrl-C to stop the sniff function from running. Assign the output to A and view the summary as you did previously. Step 3 is to repeat the sniff function, but this time filtering it only for the first 10 ICMP packets. We do this by adding more arguments to the sniff function. Assign ICMP to the filter argument and 10 to the count argument, and then press enter. Open a second terminal and send 10 ICMP packets to the Gravemind server. Return to Scapy. The capture is already stopped after 10 packets. This time, use the end summary function to add line numbers to your output. You can use the line numbers to view the details of a specific packet. Enter A with 2 in brackets. Review the detail of the protocol data units that make up this packet. For example, can you locate the IP and MAC addresses? Use the WR-PCAP function to save the captured data to a PCAP file. Note that you specify A because this is the variable where you stored the data you want saved to the file. The file is saved in your home directory. Open the file in Wireshark to view its contents. Part 3 is to create and send a custom ICMP packet. You will create an ICMP packet with a message inside the data payload. Step 1 is to use Scapy to create and send the message. First, enable sniffing for the BR internal interface. Because your current instance of Scapy is in monitoring mode, open another terminal and start a new Scapy instance. Using the send function, specify arguments for your ICMP packet. Use Gravemind's IP address 10.6.6.23. Specify ICMP as the encapsulated protocol, and then specify "this is a test" as the message. Press enter to send the packet. Return to your first Scapy instance and stop the monitoring. Assign the output to A and use InSummary to view the output. Notice that you captured an ICMP echo request and echo reply. You might also capture ARP packets if the ARP cache was empty. Step 2 is to view the ICMP echo request packet. This is your crafted packet. Notice that the data field has your message. This is a test. Part 4 is to create and send a custom TCP send packet. You will create the packet to see if a Microsoft Windows drive share is open on port 445. Step 1 is to start a sniff capture and then send a custom TCP packet to the Gravemind server. First, start the capture as you have previously, making sure to specify the interface attached to the internal network. Next, use the send function in another terminal, specifying the destination IP address. This time, specify TCP as the protocol. Set 445 as the destination port, and set the send flag. Press enter to send the packet. Step 2 is to examine the captured packets. Stop the monitoring. Use the InSummary function to view the details of the TCP packet returned by the target. Note the SendAct message is returned, which means that port 445 is open. Think about what you have learned in this lab and consider how threat actors can use crafted packets to perform reconnaissance. In addition, how might they use crafted packets to launch denial of service attacks? Read the Scapy documentation to discover how it might be used in a variety of pen testing scenarios. And have fun safely crafting packets inside your Kali VM.